Have you ever wondered how deep tech companies actually start? Well, we were too.
So in this podcast, we'll be interviewing scientists and entrepreneurs that have taken their ideas out of the lab and turned them into startups. I'm Antonia.
And I'm Christina, and this is Startup the Science. Hey everyone, thank you for tuning in to another episode of Startup the Science. Today we have an exciting episode for you with the founder and CEO of Graphenest. His name is Vitor Abrantes, and if you couldn't guess by the name of their startup, they work in graphene. They have a groundbreaking technology that mass produces high-quality graphene. We got to know Graphenest through our 2017 ADMACOM program, which was the year before Antonia and I actually joined Enum, but they've been such an important part of our network and we're so happy to have them. The team is exceptional, not just Vitor, but Bruno and Zhao. We've seen these guys at different events, so big shout out to them. They've been steadily growing the past few years, but I won't spoil their story. So go ahead and have a listen. This is Vitor, Antonia, and I talking about Graphenest. Enjoy.
Hi, Vitor, and welcome to our podcast.
Thank you for having me.
It's a pleasure. We'd love to find out more about Graphenest and also to learn a little bit more what graphene is. So when we think about graphene, I think many of us think of this magic new material that can do so many things. It's very light, very strong, but also very thin. It can conduct electricity. It can do all these things while being transparent. So can you tell us a little bit more about this strange, remarkable new material?
Sure. Actually, graphene was discovered 16 years ago, or it was first isolated 16 years ago. It was theorized in the 60s, but until Andrew Game and Konstantin Novoselov first isolated the material, they proved that graphene was possible to exist in the natural environment, and was created is a natural resource extracted from the graphite. I can explain a little more what graphene is. Basically, imagine a stack of paper as a piece of graphite, and graphene is only one sheet of this paper. The big difference is 3 million times smaller than a piece of paper, or more thinner than a piece of paper, because it's only constituted by carbon atoms with a hexagonal geometry. All the 6 lattices are constituted by carbon atoms. So it paved the way for the two-dimensional materials, because electrons can only go on the XY direction, so through the surface of this graphene sheet. So after that, a lot of research start to appear, a lot of reports on the properties, on the potential of this material, and how revolutionary can be for the next generation of our products and society in every part of the...
In every area. Because it can have so many different applications, right?
Yeah.
Because people talk about graphene, I think, the way they talk about plastics in this very generic way. But we know that scientists are working on many different kinds of graphene-based materials. So can you tell us a little bit, what are the different kinds of graphene?
Well, there are a lot of different graphene materials. The last report from the Graphene Flagship is the biggest research worldwide in any area. Is a 1.5 billion euros funding for exclusively for graphene, and they reported there are 6,000 different graphene materials, from grades to number of layers to functionalization. So we have graphene nanoplatelets, graphene oxide, reduced graphene oxide, and in between you have not only the number of layers that are connected to the quality. So single layers, 2 layers, multi-layer, few layers represent the grade of the material, because the lower the number of layers, suppose better properties on the electronics, on the conductivity, either heat or electrical, the transparency, the mechanical properties. So in this case, the relationship, as I said, graphene was the first two-dimensional material to be discovered, very similar to plastics in some sort, because there are thousands also of plastics.
I just have a question on this idea of two-dimensional material. I mean, maybe it sounds really obvious for people in the field what that is, but what exactly is a two-dimensional material? Does it simply mean, as you described before, that we go to this very tiny, tiny layer, like 30 millionths thinner than a piece of paper, and that's why it's two-dimensional? What does that exactly mean?
It's actually what I said before regarding, so there are one-dimensional materials like fluorines, two-dimensional materials like graphene, and three-dimensional materials like plastics. And most of the materials we have right now are two-dimensional materials. The big difference with the two-dimensional materials on the more research on the more fundamental way or scientific way is about the way the electrons can move in the material. So in the graphene, because it behaves like a sheet of paper, the flow and the path of the electrons can only be made on the X and Y axis. In normal materials like plastics or metals, they can go on the three directions. So plus the z direction. So that's why the big difference. And there are one-dimensional materials that can only move in one direction.
So that would be an unusual way, right? An unusual electronic property that graphene then has compared to other materials, right? How can we imagine that being applied in different industries? What can we do with this property?
Well, the electronics properties are extraordinary because right now on the digital electronic age that we are, if we discovered 60 years ago, the graphene will not be so fundamental for our society as is today, because right now everyone has a smartphone, everyone has a computer, everyone has access to internet, banking, everything are connected. And for that, we need electronics, and the electronic properties or the conductivity is one important factor to quickly connect people and connect the devices. So the fundamental properties on the graphene is can be 4 times more conductive than copper. But if you join the other properties like the tiniest or the smallest material that exists, the lightest material that was discovered and start placing into the device we use every day, you can see in the near future products like flexible printable electronics or flexible foldable smartphones that until now was not possible because the current materials we use on our touch screens, for instance, are rigid materials that are not feasible to bend and fold because they will break. That's the properties altogether that makes the graphene so amazing for the next generation products.
So we can imagine completely different screens and very, very upgraded devices than what we have now because of the very special properties that graphene has, such as being very flexible, bendable. That's part of the flexibility, right? It's also transparent or almost transparent, and it conducts electricity way better than other materials. So it sounds really good, and it also sounds like the core material that is made of it's quite available, right? So what is so difficult about making graphene? How do we make graphene?
Well, there are also a few ways, actually a dozen ways or more to produce the graphene. From the first way, that was the Scotch tape method. When anyone Googles it, will find the
What's that?
Basically, you pick up a piece of graphite and with a Scotch tape that you have in your desk, you just take a little piece, just stick to the graphite, take it off, and after that you fold it over and over again until you reach.
Till I get to a very thin layer.
Exactly, that's how they find it. Is the mechanical way. But from chemical process to more advanced like CVD, chemical vapor deposition, where you have a gas that contains carbon and you deposit and structure the graphene atom by atom on the metal substrate. There are a dozen ways. We are on the halfway. We produce on the liquid phase exfoliation method. Well, is a green method to produce the graphene. We use mechanical and chemical method to obtain and exfoliate the graphite to the nanoscale level.
Okay, so it started with the Scotch tape method. Just for clarity, when you say graphite, are we referring to like pencils? Did someone take a pencil and put that on a Scotch tape, or how did it work?
You can do that, but what the researchers did was a more fancy kind of graphite. It's called highly ordered pyrolytic graphite.
Slightly fancier than a pencil. Okay.
So it's more fancy and expensive, of course, but it was for research purpose. But today, any graphite, both synthetic base or from a natural source, are used to produce the graphene.
So now that we have the basics covered, could you tell us a little bit more about what Graphenest does and what makes you stand out from a crowd?
So Graphenest is a nanotechnology company, as you could notice, and what we do, we are a manufacturer of the custom graphene materials and provider of a turnkey solution that we call EPIC. Well, to license the technology and our proprietary technology that we call nanosonic, and also the formulations that we develop and continue developing to harvest this material into intermediate products and help the industry incorporate inside of their production line. So regarding our innovation, so we were founded in 2015, but I started together with Bruno and Rui, the other founders, in 2013, just by curiosity on the properties of graphene, the potential specifically on the batteries. There was a lot of hype early in the research regarding graphene to be able to charge, or a battery with graphene to be able to charge in a few seconds and have 3, 4, 5 times the capacity comparing to what we have currently on our laptops, smartphones, everything. Because we were students, I was taking my master in materials engineering, and both Bruno and Rui chemical engineering, PhD and master. So when we tried to buy 1 gram of graphene, we found out the price was ridiculous. We are talking about 200 to 250 euros per gram in 2013, because we didn't have the resources to buy it. We start making research on how to produce on the lab, and what we did was replicating a lot of these methods to produce the material on the lab, from Hammer's method to obtain graphene oxide and then reduce it, to even using a blender and a kitchen washing to making the exfoliation. And what we find out was too expensive to produce, to clean, and it was not efficient, because by using strong acids and strong oxidants, you start losing properties on the materials, specifically the electronic or the electrical conductive properties, because start introducing a lot of defects. So we start coming up with a early concept of our technology that we call now nanosonic. And well, we expose ourselves and propose, basically validate this technology, and we raise the seed investment from Portugal Ventures. And that's how we were born in 2015 to validate, make the first real lab scale prototype that we did in 2016. And right now, well, there are a lot of things that happen between then and now, but we already reached the full validation. We are piloting actually the technology at industrial scale, and things are going well on our side.
That's great. But one question is still looming for me. You started Graphenest by making DIY graphene? Is that right?
It was initially, right?
Yeah, you can find on the YouTube, there are a lot of do-it-yourself graphene methods that you can do in your kitchen. Some of them is not recommended because can require some chemistry, but yeah.
So this is what we're all doing now during Corona times. We're gonna all try to make graphene. So you started in 2015 by experimenting in your different kitchens with different types of graphene and the lab. And we know that you've made a lot of progress because we're very proud of you, and we've also tried to support you as much as we could along the way. And we know that you've now opened your own production facility, and that's very exciting. And maybe you can tell us a little bit more about that, right? Because there are a lot of graphene startups out there, but not all of them or most of them don't have their own facility where they actually make graphene at scale. So can you tell us a bit about that?
Sure. Actually, our facility, we just finished early January. So we start producing the first batches a few weeks ago, and start exporting internationally to a few of our clients. But specifically regarding the technology is in comparison with the do-it-yourself kind of methods and the other competitors, is about first the efficiency of the system, how much percentage of the graphite is converted to graphene in terms of its grade.
What percentage do you convert, just out of curiosity? What's a good percentage?
Right now we are obtaining 75% conversion on the graphene. That in comparison, we are talking about between 25 to 40% higher than the normal technologies or the normal methods that are currently in the market. And on top of that, because we don't use harmful chemicals and we can recover these materials, so we can separate the graphene from the other chemicals. In this case, we use solvents, organic solvents to produce material, and we can after we produce the graphene, we separate by grades the graphene, and we recover the organic solvents and the micromized graphite that was not converted into graphene, and reuse it again on the production. And with both of these innovations, we are able to produce it on the cost-efficient level.
You mentioned earlier when we talked about graphene in general, some of the potential applications of it, but who are at the moment, what type of clients do you have? Who are the buyers of graphene at the moment, and what do they do with it once they buy it?
99% of our clients, we are on the confidential agreement kind of collaboration, but we are talking about from electronics companies, automotive, aerospace, packaging.
So pretty much anything.
Not anything, but is on the major markets, medical devices. We are, because inside of an industry like automotive, we are talking about multiple verticals inside of batteries, plastics, structural components. We are talking about electronics. We are talking about sensors. There are a lot of sub-segments inside of any of the three major markets we are focused on, that of course they converge. A lot of applications with that or specific applications on automotive can be applied to aerospace, of course with different compliance and requirements, but are the same kind of application.
So basically, Graphenest can be everywhere. And that is great to hear. I'm so happy that you guys have been growing so quickly. You have your facility now. It's amazing. Of course, right now, things aren't moving forward as we'd like them to, thanks to Corona. But I would like to know what's in store in the future for Graphenest. At least in an ideal future, what do you see for Graphenest?
Well, that's a great question. In the ideal future, let me separate into time frames. On the short term, my goal and our company goals are to showcase and have early adoption, as well as continue establishing the partnerships at industrial scale to evaluate our materials and help the industry to incorporate the material. And out to long term, that is a consequence of this first goal, is to see every major factory out there to have our technology incorporated inside or nearby the factory to supply the required materials to go into the supply chain.
Pretty much everywhere.
You can say so. Part of our business model is not just to grow in one location, it's actually licensing the technology. So the IP, we build the equipment, install, and put our experts, our employees inside of the factory, producing the material and controlling the quality for our customers. So implement the technology directly on our supply chain. That's one of our innovations, because that way we don't need to grow in the one single space, and with that we don't have will not have the logistic problems, because graphite is everywhere. Right now we have 16 suppliers of graphite worldwide, from China to Canada, Brazil, Mozambique in Africa, Sri Lanka, Sweden. So for each customer, we can select and work with them to select exactly the solution they require. As I said before, if we use a graphite like what we use in the pencil, we will obtain a certain quality of the graphene. But if we use more higher quality graphite, like the highly ordered pyrolytic graphite, we will obtain a different quality of the graphene that can be applied to different applications, like the electronics.
So this is the reason why you have so many different suppliers of graphite?
Exactly.
Right, so that you can find, depending on the application and the customer's needs, you can find the right graphite first that you can then convert into a graphene with certain properties.
Yeah, we already made portfolio, let's say. We already tested and validated most of these graphites. And as we move forward with these partnerships, we select the best graphite, taking into account not only the requirements, the properties that the customer has, but also the financial, because the cost is also one of the main concerns for customers. Ultimately, what we can bring to the market is a range of prices from €5 per kilogram to €1,000 per kilogram.
So the one that we would make in our kitchen would be more in the $5 range, maybe. you can supply the really good one.
Exactly, but the thing is on the industrial scale, constant quality. That's the part that we took a lot of time in the last year and a half validating, is the reliability of the system.
Cool. I know that Christina had a special question for you regarding some of your applications.
I actually thought that maybe I should have asked it before talking about the future when you were talking about the applications. But I just was wondering what your favorite project you've been involved with was. And I have a boat in mind, but hint, hint, wink, wink.
Actually, there are a couple of projects that we did. That one of them was the kayak, the prototype we built with a kayak manufacturer. Basically, what we did there was functionalizing the epoxy resin that goes to build the kayaks. The same kind of epoxy resin that are used for boats, for aircrafts, for automotive, for a lot of applications. And we took the challenge to do that. We build after we validate and showcase in front of 500 people. When we bring the kayak to Boston, during our demo day with the US Air Force and Techstars. Of course, it was a big moment for us, having 4-star generals picking up and seeing. Actually, we put person with only a hand hanging the kayak with almost 6 meters, 5 meters and 75, with 9 kilograms full equipped.
9 kilos.
Yes, exactly. Typically, these kayaks range higher in terms of weight, higher than 12 kilograms. But because we were able to enhance the mechanical properties of the structure, the carbon fiber, the manufacturer was able to reduce the fiber, because only one layer was enough to make the kayak. That's why the weight reduction was so drastic on the final prototype.
I'm still stuck on the fact that a guy could just hold it over his head with one hand.
Actually, it was not a guy. Actually, it was a girl that picked it up from the.
Apologies for making assumptions. Wow.
Assumptions.
Yeah.
So that's the magic of graphene. That's very cool.
The other project that one of the applications we developed was a coating that can be applied to any kind of surface, flexible or rigid, to emit light. It's a kind of electroluminescence kind of system, so can be used in multiple surface kind of systems, and you just need a battery or some very small amount of energy to light the area. It's not like a spot, not a LED. You can check on our LinkedIn. We usually post some of our technologies that we develop for our customers, the ones that we can publish, of course, but there are a lot of things going on, and some will be revolutionary. Cannot be so impactful like seeing the lightest kayak in the world or the light on any surface, but can change the way we communicate, the way we interact with other people. And that's what the goal of Graphenest. It changed the world one step of a time.
Oh, that's a lovely goal.
Well done, guys. I was wondering, because we're coming towards the end of our recording and we've asked you so many questions. You've been very kind and patient and explained to us what graphene is. Me and Christina have no idea about materials other than what we hear from the people we interview, so that's great. But since we've asked you so many things, this is your chance to ask not just us, but all of our listeners, anything you might want or need for Graphenest. Is there one wish you have? Are you looking for investment, customers, partners? What would you like to ask the world?
Well, one of the things I'm personally publishing in the next few days actually is a request for partnerships, investors, either research facilities, research institutes, or even other corporations. One of the applications or the properties we can obtain is as I said before, the gas barrier that can be applied to the masks for protection. We believe, of course, we don't have all the resources in terms of in the lab, and of course the investment needed to do so, but we have a lot of fundamental early applied research to use the graphene inside the textile or the textile non-textile kind that is used on the masks today. So it could be a game changer for a more protective equipment for this and future pandemics. That's a call that we will make. Of course, we continue. One of our priorities that we have right now is actually continue growing industrial relationships. Anyone that would like to learn more about our technology and would like to test and discuss a collaboration, we are open to it. So that's my ask for
the world,
listeners.
That's great. All right. Well, thank you very much for joining us today. We'll put all of your contact information in the description. Thank you so much for joining us today, and we'll talk to you soon.
Thank you.
Thanks for listening to Start Up the Science.
If you like our show and want to know more about what we do, check out our website at inam.berlin.
And don't forget to leave us a review. Until next time.